Hello and welcome. We are looking at Year 11 Specialist Maths Statistics area of study, and we're going to do some simulations involving Google Sheets. We're going to look at doing some random sampling from a normally distributed population. So let's consider this scenario. A person's height is normally distributed in the population. We've got males and females in our population, and we've got some population parameters. So our male height and mean height and standard deviation are these quantities respectively, while the female have also a mean height and a standard deviation. And from that population, we're going to randomly sample 25 people, and we're going to observe the sample mean of heights of that sample. So we're going to repeat that random sampling a number of times in our simulation, and we're going to examine the distribution of sample means of the height. Once we've done that, we can inquire into some of the statistics and the properties of the distribution. So we're going to determine the minimum, maximum sample means observed and estimate the standard deviation of the distribution of sample means, and we're going to examine the distribution and think about, well, what's likely to be the expected value of the sample means. Let's get to it. Okay, so first off, in Google Sheets, we can set up the population parameters for heights in a little table in the corner here. So we want to have in rows male and female parameters of mean and standard deviation respectively, like so. And then we're going to draw on this table of parameters to simulate our population. Okay, you can then, if you have them entered here, you can manually change them if you want to examine having a population with different parameters. So the first thing we need to do is set up our population. So in our population, we need to, so we can take random samples from the population, we're going to set up a numbers column. Okay, so we need to have some repeated numbers, 1, 2, 3, 4, 5, 6, 7, and so on. And then what we're going to do is fill down this count all the way down. Actually, what we need to do, let's delete that. Let's start bit again. Let's come up with a formula that's going to help us to produce a list of numbers all the way down. We're going to use our row formula. So enter equals a row, open bracket, close bracket, and that's going to return the row number that the formula is assigned to in that cell. But we don't want to start with the number 7, we want to start with the number 1. So I'm going to subtract 6. There it is. So you can see the result now of the cell is going to be the number 1. So if I highlight that cell and click and drag from the corner down, I'm able to now, there we go, produce a list of numbers down the side. Now, how many do we want in our population? We want a few. So let's copy that set so far, and let's go down to the bottom part of our column. So we're going to use our short from that. Once that's highlighted and you press copy, Control C, we can press Control Shift and down, and that sends it all the way down the column to the last row in the Google Sheet. So I have selected, I've added another extra 1,000 rows, so I've got 2,000 rows there at the moment, and I'm going to paste, Control V. Alright, so there we have it. We've got a number of cells all the way, almost 2,000. Let's try and squeeze in a few more. I need, how many more do I need? About 4 more. Alright, so let's get 2,000, nice round number. Oh, 1 more. Alright, let's add 1 more. Let's get 2,000 members of our population. There it is. Okay, fantastic. Let's go back up to the top, Control up. There we go. Now, so we've got 1 to 2,000. It's going to be 2,000 members of our population. Let's simulate some population heights. Right, now the height of our population is going to be done using this neat little formula. We've got we're going to draw on the parameters of male and females in our population. So let's set up a little population number. Let's put in population height. All right, and it's going to be measured in centimeters. Let's get an example of the formula so we know what it's going to look like. We've got two members, males and females, so let's come up with an if statement that we can randomly choose between males and females. So if rand, which is our random number generator between 0 and 1, if, say, that is less than 0.5, so 50% is allotted to a certain category, which is, let's say we're going to return males, and otherwise we're going to return females. So that allows us to say we've got some males, we've got some females. All right, and that randomly generates every time I recalculate the sheet. Okay, so from that, let's now, instead of using male and females in our formula, let's assign a height. So we want the height to be normally distributed. So to achieve that, we're going to use the norm inverse function. Okay, and we need, and that relies on a probability that is given. So we're going to randomly generate a probability from 0 to 1, and then we're going to use the norm inverse function to return a height that is normally distributed. To do that, we need some parameters of our distribution. We're going to draw on the mean of males. We need a mean. And the second part is we need a standard deviation. There it is. And that gives us it's going to randomly generate a height for males. There it is, and you can see an example is 185 centimeters. All right, now I'm going to copy this formula down, so I want to fix on those cells there pertaining to the mean standard deviation of males. All right, now let's do the same for females. So we need norm inverse, and we put in a probability, randomly generate a probability. And now we need parameters for females. We need a mean, comma, and the next part in the formula we need to put the standard deviation for females. And there we have it. So let's lock in those cells with dollar signs. Oopsies, I lost my formula. Let's come back to it. There it is. Okay. Let's lock in those cells with dollar signs. And so when we copy the formula down, we're not shifting that cell reference. Perfect. So here's possibly a female height, and I recalculate and I get possibly a male height. All right, fantastic. So that looks like a good formula I'm going to use. I'm just going to copy that down into my cell, and there it is, the first reference. There's person number 1 with that height. Now let's copy that all the way down. Go away, Westlab. I'm going to copy that cell and then press Control, Shift and down to go to the very last cell in my column, and I press Control V to paste. Fantastic. So there's 2,000 members of the population with their heights. Now let's just fix those numbers a little bit. I want less decimal places. There we go. Maybe just 1 decimal place is sufficient. Perfect. Much better. Alright, let's go back up to the top. Control up on the keyboard. Excellent. Now, there's our population. We've done it. We've got 2,000 members in our population with heights, and they are randomly generated from a normal distribution. Now, the next thing we want to be able to sample. We want to take samples from this distribution. Alright, so let's set up a column for random samples. Alright, now let's put this one maybe up here. Now, for each sample, we're going to set them up in sections here, in columns. For each sample, we want to take a sample mean. That's the main thing we're going to look at. So the sample mean is going to be calculated right underneath here on top, so we can see it. So that box is there for the sample mean. Now let's create a sample. So in producing samples, we have to randomly select and look up a member of our population. So this is going to be done using what's called a lookup function. So let's use the VLOOKUP. Here it is, VLOOKUP. That's going to look up a vertical column. Now we need a reference number that we're going to look up. We're going to reference the population number. So we've got 2,000 members of our population. So let's randomly look up a member of the population. So we're going to use the rand_between function. That's going to randomly generate a number between 1 to 2,000. Okay. Now, once we randomly choose a number between 1 to 2,000, that's going to refer to one of our population members. But we don't want their number, we want to return their height. So what we need to do is now consider the full range that we're looking up. So we're starting at A7, and we go all the way down to the last member in our population on cell 2006 was my last cell. So the way I selected that, I just pressed Control Shift and down, and I selected sorry, that selected the whole range there. Now this is my fixed range, so I want to lock them in with $signs on the column and on the row. Alright. Okay, now the last part we need to do in our formula is to reference which column we want to get the results from. So from our range, A7 down to B2006, that covers the whole range of our population of number and height. We want to return numbers from the second column, just the heights. So we have to put second column there. Okay, and we want to return exactly that number with some random number from 1 to 2,000. So the syntax, what we need to put next is writing true. Okay, and that should do it. Let's have a look. Okay, once the formula is in, just always good to double check to see that it's correct. So should be VLOOKUP rand between 1 to 2,000. Then you've got your selected range of your population, comma 2, comma true. Yes, there it is. There's our population. There's our sample measure of height from our population. Now, let's get a couple. And there we go. So all we have to do is click and drag, and we can get some random sampling from our population. Now, how many do we want? Well, we want 25. Okay, so we come down to row 32 here, and that gives us our 25 members in our sample. We can highlight our sample and just container. Let's put a nice border around it. There we go. Alright, so there's our sample of 25, and let's work out the sample mean now. So we're going to work out an average for our mean. We're going to use the average function. Okay, average. Now let's highlight the sample. So we click and drag and highlight the range containing the sample from row 8 down to 32. That covers 25 members there. Close bracket. Alright, so there's our sample of 25 with a sample mean. Alright, now our job is to repeat our experiment, our random sampling, a number of times for our simulation. We want a good, decent number of times to have a significant simulation occurring. So let's go ahead and do that. So let's copy our whole sample, including the sample mean. And we can go to the next column and press paste. Nice and easy. We want to be able to keep doing that each time. And let's get a large number going. So let's again highlight the row, and we're going to come down and grab our corner, and then we're just going to click and drag across and let it slide all the way across, and see how far we can get. Okay, so that's just A to Z. There we have it. We might want to go further than that. So let's start. For Google Sheets, we have to push the screen across with our copying to get more columns popping up. So again, let's highlight the whole lot and press Control-Shift across to highlight the whole lot. And let's go up to have a look. Yes, let's copy that whole range we've highlighted. Perfect. Now, all we have to do is come to the last column, put our starting point there, and I just want to copy and paste. I want to paste over this column, and that will actually bump to the right and open up new columns as well. So press Control V. There we go. We get to the end, press Control V again. It's on our on our clipboard, so we can just paste each time. And that way we're able to get a larger simulation of all random sampling occurring. And we can do that process again, highlight the whole lot, press Control, Shift, and across. And that grabs the whole lot now that we've done. Copy. Perfect. Now, let's come to do that one more time. And we've got a larger group that we've copied. And now when we paste, we're pasting in the larger group. And it's making Google Sheets think a little harder, but that's all right. It's Google. They can handle it. Let's do some more random sampling. There we go. Paste. Come to the end. How far do we want? We want a good spattering of simulated random sampling. We want to do this a number of times. And this way, we're able to get some more detail in our distribution. And we can just keep going across. Control, Shift. Might be a little tedious, but in the end, we want to get some accurate results in our distribution. And it's just an easy copy and paste job each time to get more and more columns. So we're getting there now. AGZ, it's not bad. Let's try one more. How far can we go? Paste, one more. I'm sure we'll reach a limit soon enough where Google Sheets will swear at us and say, "Oh, that's enough." Yes, there we go. All right, not a problem. Let's pause there. All right, let's come back. Now, heaps of random samples. Now, as we can see, we've got quite a variety of sample means there, 170, 169, 172, 173, and so on. Now let's start to examine the distribution in that all these sample means. So some things we can determine are what are the minimum in our sample mean. It gives us a rough measure of spread in this case. So we're going to use the min function. Now our first sample mean was here. So it's starting at D7 and then going all the way across. So to get to the last bit, we're going to press Control, Shift, and the right key, press across, and it goes to the very last column in that row. There it is. So AGZ7, right. So it's quite a big range. There we have it. So after Google Sheets has a little think, challenging its memory. There we go. It's going to give us a minimum result. Okay, 162. Let's get a maximum sample mean. Now, when we get this, just to tidy up some of the formatting, we might want to wrap the text around. So hit wrap in the middle here, and that brings it down, and so we can just make it neater. our work, presenting our headings. Ooh, this one, wrap text, there we go. So let's do the same using the max function, starting at the first cell, press Control Shift across, go to the very last cell. There we go. So we've got the max and the min value. And why not, let's just get a nice simple measure of range, which is the difference between the maximum value and the minimum value. And oh, look what I've done, I've killed my cell. So let's go undo when we make a mistake. Alright, so range goes in this cell. And we want the maximum value minus the minimum value. Come on, Google Sheets, hurry up. Okay, so a crude measure of spread is our range, and as soon as Google Sheets stops thinking, we can see that we have a range of around about 14 centimeters. Okay, now one way to approximate our standard deviation of this distribution we're looking at of sample means is using our range. We can say, well, approximately the range encompasses 100% of all possible values. Okay, and if we examine the normal distribution, we can see that we have around about 6 standard deviations across the whole range. All right, that encompasses approximately 6 standard deviations is approximately 100%. So if we had our range and we divide that by 6, we get an approximate standard deviation of our sample means. Okay, which is about 2.4. Let's emphasize that's just an approximation. Okay, so that's just a neat little way of approximating your standard deviation from a normal distribution. It's roughly a sixth of the range. Okay, now what are we expecting to be the average of the average? What's the mean or expected value of the distribution of all our sample means? So let's work that out. Oop. Let's just wrap this text. Okay. Now, essentially what we need is just, again, an average function. And this time we're taking average of all the sample means. So select the first cell, Control Shift across. There it is. So now, what do you think that might be? Well, if we know a little bit about the distribution of sample means, we'll see that this value will be something similar to that of the population. Okay, and one thing we didn't do before was examine our population more in detail, such as we might want to know what is the parameters of our population, of our group population of male and females together. So let's get that while we're here. Let's get the mean of population. The population mean, in this case, will just be the average of all our population values. So select the first one, Control Shift down to get the very last row. There it is. And we can also get the standard deviation of the population. And we're going to use the formula, standard deviation formula, of this one. Thank you, Julie. Let's wrap that text around. Okay, so we're going to use the standard deviation of the population. So this is the formula we want. STDEV-P, standard deviation of an entire population. We select the first cell, Control Shift down, we go, select the whole range. Okay. And we can see for our population of male and female heights, we've got an average, a mean of about 170.8, while the standard deviation of the population is 11.6. Okay, so we're going to see how that relates to the expected value of the sample means. And we can see there's something interesting going on there. The expected value of sample means is the same as the population mean. Interesting. Wonder how the standard deviations relate. The standard deviation of the sample means, distribution of sample means compared to the standard deviation of the population. Well, it's certainly less, but how much less, it remains to be seen. Well, one last thing that is worthwhile doing is examining the distribution graphically. So we're just going to, from here, select all sample means. So click on the first cell here, press Control Shift across. There it is. And we're going to insert a chart. Now Google Sheets likes to give us our recommendations, and there it is. It picks it straight away. An excellent histogram. Hopefully you do get a histogram as your recommended chart, and that's spot on what we want. So let's insert that. Where is it? Come back. There we go. Lovely. Alright, so we can just add some nice some axes labels and a title. This is the distribution of sample means of heights. There we have it. And you can see it looks approximately normal as well. Interesting. So I wonder what we need to do to increase the accuracy of the shape of this. Well, perhaps we need to do more random sampling and increase the amount of random samplers for which we're looking at the distribution of. Or we might want to also think about changing our sample size. Instead of having a sample size of 25, we could increase our sample size, and that can affect the shape and structure of our distribution. Alright, so there we have it, and then now we can think about exploring and answering some of the thinking questions about this little simulation we produced. Thank you very much for watching.